Intensity is defined as the amount of energy moving through an area in a certain amount of time. So we have some area, A, which has some amount of energy moving through it in some amount of time. We have defined the rate at which energy changes and is called power. So we end up with an equation for intensity as power over area. The label we have for this is watts per square meter. So what do we mean by area? Sound waves are three-dimensional waves. If we assume a sound, say a siren, is being emitted from the car in the diagram, the person on the right can hear the sound. So can the person on the left, and also the person above. If there was someone in front of the car, they would also hear that sound. Those sound waves are traveling out in all directions. Let's assume the power of the sound does not change, so the energy being given off is doing so at a constant rate. At the source, the wave traveling outward takes up a certain area. As it travels further away from the source, the surface area of the wave increases. We can see from our equation, then, that the intensity of the sound decreases. Really, you probably don't need the equation to tell you this. If you stand close to a siren, you can definitely tell a difference in the intensity than if you are standing further away. Which one makes your ears hurt? If we want to be more specific in our measurements, we can substitute in the equation for surface area. So if we know how far away we are from a sound, we can determine the intensity of the sound at that point. When we talk about the sound intensity level, we are referring to how the human ear can perceive sounds. So we have to start with a 0 point somewhere. And in this case, we use the 0 point as the lowest intensity of sound that the human ear can possibly hear. This point, called I naught, is defined as 1 times 10 to the negative 12 watts per meter squared. Now, it is entirely possible that someone out there can perceive something less intense. This is just what we have defined as that lower limit. If we think about the wavelength involved with this, we are looking at a vibration that is actually about the size of one molecule. Have you ever been in a completely silent room and listened to the quiet? Even if there is no other sound, you can actually hear the air moving. You can hear any intensity above this level. Now, at a certain point, this starts to get painful. Again, this varies for everyone, but it is generally agreed that 1 watt per square meter will really start to get uncomfortable. You can still hear at this point and above, it just becomes less fun. In fact, your ears can withstand another 10,000 times intensity before they finally give up and rupture. Look at that range for a minute. We are talking about the human ear being able to detect sounds between 1 times 10 to the negative 12 watts per square meter and 10,000 watts per square meter. Marvel at that for a second, because the human body really is pretty amazing. To be honest, this is a ridiculous number that we really can't do much with. It's just too big. So what we have done is devise a scale that allows us to deal with this huge range of sound intensity. This is where the decibel comes in. The decibel is basically a ratio of the intensity of a sound compared to the faintest level we can hear, which we define as I naught. This ratio can be anywhere between 1 and 1 times 10 to the 16th, which again is a terrible number to have to do math with. So what we do is take the log of that ratio. But that's not all. Notice the prefix in this unit. It is deci, which means a tenth. So when we talk about a decibel, we are actually talking about a tenth of a bell. So we are going to multiply this by 10. So when you talk about the decibels of a sound, what you're actually looking at is the range of intensity compared to the faintest intensity that we have, times a log 10. Table 17.2 in your textbook lists some common sound intensities. Normal conversation comes in right at 60 decibels. A whisper is about 20. A classroom lecture is about 80. It is interesting to note that prolonged daily exposure to sounds at and above 85 decibels is not recommended without hearing protection.